Hello everyone, this is Yash and today we'll be looking at the question ugly number 2. Let's get started. The question says an ugly number is a positive integer whose prime factors are limited to 2, 3 and 5. Given an integer n, return the nth ugly number. Let's copy the bool function from our previous code, paste it, and simply run a for loop for int itr equals to 1 itr. We know we don't need a breaking condition because that will be our return statement inside the loop. Now what we are going to do here is we don't need a 0 condition as well because the minimum value that will be passed is 1. It equals to 1 itr plus plus. Okay, if is ugly, if the value is ugly, then we reduce n, and if n is 0, we return itr. In default case, let's just return -1. Okay, it results in a TLE for the last few cases. Let's try a different optimized approach. In that, what we are going to do is we are going to create a set. Let's create a global so that it's easy when we pass it, and name it as no duplicates allowed, and create a priority queue with a min heap. FIFO. Now simply push FIFO.push 1 as a first value. What we are going to do here is we know 1 is an ugly number, and multiplying it by 2, 3 or 5 will result in an ugly number, and doing the same to the results will also result into an ugly number. So what we are going to do is multiply this value that we have on a top with 2, 3 and 5 and check whether that value is the nth value. How we are going to do is we are going to start a while loop, while n minus minus, and simply check if n is 0. We are going to return FIFO.top. If n is not 0, what we are going to do is if we are going to check, okay, first we need the value int itr equals to FIFO.top and FIFO.pop. Easy. Now we have the value in our hand. Let's check if, now what the set is for is because once we create 2, 3 and 5, we are going to multiply 2 with 3 and 5. So the resultants will be 4, 6 and 10. The same is going to happen with 3. It's going to be multiplied by 2, 3 and 5. The results will be 6, 9 and 15. So the 6 comes twice, but we only need it once. So we will check if our helper function will be used. We will check whether the value is present in the set or not by multiplying it by 2. If the value is present, the helper function will push it. If it's not, then we can just ignore it. So for the first condition, if it's not present, simply just push that value, FIFO.push itr into 2. If it is not present in our set, we are going to do this for 3 and 5. 3, same with 5. Okay, once we have done this, we need a default case as well, return -1 and our helper function. We are going to name it as helper, and an integer value will be passed. Just simply check whether the value is present or not. Okay, so if nda dot find val, okay, this function finds the value. If it is present, then well and good. If it's not present, then it gives nda dot end. That is the end of our stack. So we will insert the value to replace duplicates when it occurs later, and return true. Default case will be returning false. Now that we have all these value asides, it should run, but there is a single condition that would fail. Let me just try to dry run this. Yeah, it runs for smaller test case, but when we use a larger test case like this, multiplying that integer with 2 might give us an error, or multiplying it by 3 or 5. Okay, not in this case, but let me just exceed the value. Yeah, integer value flow, the value overflows because it's not supported more than 2 to the power 31 minus 1. So instead of just mindlessly multiplying, what we are going to do is, if itr is less than equal to our int max by 2, and so what we are checking, if the current value is less than or equal to int max by 2, then we can go with it. Same condition is added here. Instead of 2 we are going to do 3, and instead of 2 here we are going to do 5. Now this error should be tackled because we are checking if the value is less than int max or equal to int max once it's multiplied. Yeah, now let's just submit it. Okay, I'll be giving the solution link in the description. Thank you everyone.